Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 13 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we are looking for the rate of change of y with respect to x, and we do know that it is a function. All right, so if we are not sure what to do and how to kind of quickly look at this, let me show you one method that will always work. It might take a little bit more time, but it's creating a table of values. And so let's create a table of values. And what I want to do is when I'm dealing with rate of change, I'm looking for that unit rate, right? I want that step on the x to be 1. So let's go ahead and start with a 0. Okay, so I'm just going to plug these in. 0 plus 7y equals negative 14. So that's just gone. Divided by 7. Okay, that seems pretty simple. So in this case, y is negative 2. All right, so let me step this. For every unit that x increases, right, how does that y value change? That's what I'm looking for. So what if my x is 1? All right, so I'm going to have 1 plus 7y equals negative 14. Subtract 1 from both sides. 7y equals negative 15. So that's not going to be even. Let's get that 7. All right, so that's going to be y equals negative 15 sevenths. I can do negative 2 and 1/7. Let's make that a seventh there. All right, so that change right there is negative 7. Let's do one more just to verify. I mean, it looks linear, but it should be that same constant rate. So if that x is 2, let's do this right here. 2 plus 7y equals negative 14. We're going to subtract 2, and that's going to be 7y equals negative 16. Divided by 7. Y equals negative 16 sevenths. 7 go into 16 twice, and there's 2 left. Okay, so I see this incremental change. First off, it's not proportional. That's fine. It's not asking us about that, but it's not going through the origin. And you see how I keep inching down 1/7. So it's a minus 1/7. So I'm thinking, right, we've got this right here. Now, I said there's a few different ways we could do this. We can do it kind of the longer way, table of values, and you can just kind of look at that change in y as long as your change in x is plus 1, right? So you can always find that rate of change if you can create a table of values and just make your x value increase 1 each time. Whatever you get for your y value, that's going to be your rate of change. Because remember, our constant, right, is going to be that y over x. Now, what can we do if we didn't want to create a table of values? Well, this is given to us in standard form. So this is ax plus by equals c, right? So we know that if we can get it, so there's our standard form. There's not really an a, it's a 1. But if we could do the slope-intercept form, we should know that that m value is the slope. So all we need to do is rewrite this in slope-intercept form. Okay, so when we're doing slope-intercept form, what we're doing is we are solving for y. So how do we solve for y? Well, first let's go ahead and get this x. We're going to subtract the x from both sides. That's going to be just 7y. And that's going to end up being, I can't do anything with the negative 14, negative x, so I'm just going to list them like this. Negative 14, negative x. I'll just kind of do it in that order. Now all I need to do is isolate the y. So I could do it like this, and we're good. And let me go ahead and rewrite this. I could leave it as negative x over 7, or I could do negative 1/7 x minus, and this is 14 over 7, so that's going to be 2. And that is my y-intercept. So my answer here is C.